In this video, let's take a look at right triangle trig. So first, let's go over some vocabulary. We use theta, which is the Greek symbol, looks like a O with a little curly, like a cursive capital O. And that is to label an unknown angle. So it's a variable we use to represent an unknown angle. Let me write that out. An unknown angle. And then we consider adjacent side, opposite side, and hypotenuse in relation to theta. So where theta is located in your triangle, the one beside it that's not the hypotenuse, we call the adjacent side. So let's put that one in green. That is beside, let me write this a little better. It's the side of the triangle beside theta, but not the hypotenuse. All right. The hypotenuse is always across from the right angle, like it's always been, and it's the longest side of the right triangle. So it's across from the right angle. And as always, it's the longest side of the right triangle. Then opposite is the side that is opposite of theta. So that's the one that's right across the triangle. It's not touching theta. So it's across from theta in the triangle. Then we use our trig ratios to help us solve problems. So a way to keep this straight is think of sine of theta equals opposite over hypotenuse. And you can think of the phrase some old hippie to help you keep that in order. Some goes with sine, old goes with opposite, and hippie goes with hypotenuse. So some old hippie, sine of theta equals opposite over hypotenuse. Then caught another hippie. So caught goes with cosine, another goes with adjacent, and hippie goes with hypotenuse. So caught another hippie helps us remember that the cosine of theta equals adjacent over hypotenuse. And then tripping over apples. So that helps us remember the tangent of theta equals opposite over adjacent, tripping over apples. So let's take a look at some examples of how this helps us to set up the trig ratios. So use the definitions of trig functions to label the correct sides of the triangle, then find the length of the third side and the values of the 5 trig ratios. All right, so if we know sine of theta equals 4 over 5, think of some old hippie. So some old hippie helps us remember that sine of theta equals opposite over hypotenuse. So opposite of theta is the side across from theta. So I'm going to put the 4 right there. And the hypotenuse is always across from the right angle. So I'm going to put the 5 where the hypotenuse would be. And then we need to use the Pythagorean theorem. Let's write down the Pythagorean theorem is when you have a right triangle and you have 2 legs and the hypotenuse. We can say that the leg squared plus the leg squared equals the hypotenuse squared, which we also know is a shorthand way to write it is a squared plus b squared equals c squared. So the legs are your a and your b. It doesn't matter which one you write first. And your hypotenuse is the c. So let's set up Pythagorean theorem to solve for the missing side. So I'm going to say 4 squared. I'm just going to call this missing side b. So 4 squared plus b squared equals 5 squared. So 4 squared is 16. 5 squared is 25. I can subtract 16 from both sides and I get b squared equals 9. And then I need to take the square root of both sides and I get 3. So the missing side, which I just labeled as b, is equal to 3. Now I can set up the rest of my trig ratios. So cosine of theta means cosine is caught another hippie. So adjacent to theta is 3, and then the hypotenuse was 5. So think cot another hippie means to put adjacent over hypotenuse right there. Let me write that a little smaller. Adjacent over hypotenuse, which in this case would be 3 over 5. Then tangent of theta. So tangent is tripping over apples. So over is opposite of theta, so that would be 4. Then apples is adjacent to theta, which would be 3. So over apples would be 4 is opposite of theta over 3, which is adjacent to theta. Now secant, cosecant, and cotangent. Secant is the inverse of cosine. So once you know cosine is 3 over 5, secant would be 5 over 3. You just switch it around. The cosecant is the inverse of sine. So once you know sine was given as 4 over 5, cosecant would be 5 over 4. Then cotangent is the inverse of tangent. So you just have to know tangent is 4 over 3. Cotangent would be 3 over 4. All right, let's look at another example. So if they gave us the secant is 13 over 5, the secant of theta, then think about what we just said. The secant, notice over here, was the inverse of cosine. I'm going to write it with the same color. So that's the inverse of cosine. Cosine is cot another hippie. So this would be, I put that in the wrong place. I'm just realizing. Secant. I meant to write this up here. Secant is the inverse of cosine. Cosine is adjacent over hypotenuse. So this is going to have to be hypotenuse over adjacent. So the hypotenuse is 13, and then adjacent to theta is the one right beside theta, which is 5. Now, let's use Pythagorean Theorem to help us figure out the missing side of the triangle. So I'm just going to call that, let's just call that A. So I'm going to say A squared plus 5 squared equals 13 squared. And so A squared plus 25 equals 169. I can subtract 25 from both sides and I get 144. And then I can take the square root of both sides and I get A, which equals 12 for that third side, the other leg, the third side of my triangle. Now I've got everything I need to write the rest of my trig ratios. So sine, let's see, I think I wrote those in blue. Sine is some old hippie. So opposite over hypotenuse. So opposite of theta is 12. Hypotenuse is 13. So I need to write that would equal 12 over 13. All right. Cot goes with cosine. So cot another hippie. That's how I remember that. So adjacent to theta is the 5. And the hypotenuse is 13. So that would be 5 over 13. And then tangent is tripping over apples. So opposite over adjacent. So look at theta. Opposite is 12 and adjacent is 5. So in that order, I need to put 12 over 5. Okay, so cosecant. Let me see what color I used over here for cosecant. It was green. Cosecant is the inverse of sine. So I know sine was 12 over 13. Cosecant is 13 over 12. And then for tangent, I had 12 over 5. So cotangent is 5 over 12 because that is the inverse of tangent. Okay, so that's it for those two examples. Let's look at a few more. So using trig ratios, they want us to solve for the missing angle or side of these triangles. So you just want to look at what you're given. You've got theta. You've got the adjacent side is 4 and the hypotenuse is 5. So you want to think what goes with adjacent and hypotenuse. So adjacent and hypotenuse goes with cosine. So that's the one I need to solve this problem. So then you want to set it up. Cosine of theta equals adjacent over hypotenuse. Caught another hippie. That helps me remember that. We don't know what theta is. That's what we're going to find. So just keep that as theta. Adjacent was 4, hypotenuse was 5, and then we can type this in the calculator. So to get rid of cosine, you have to take the inverse cosine. And that's just a button we're going to type in our calculator. So we're going to do inverse cosine of both sides of this equation. And what that's going to do is help cancel out cosine and leave us with theta by itself. And then we'll get the angle from Desmos. Okay, so we just have to type in the inverse cosine. So you go to functions, go to trig, and find the cosine with the little -1 on it. That's the inverse cosine. Then type 4/5 and make sure in that little wrench that you've hit degrees. It usually is on radians, so just make sure you hit degree. And then you want to round to the nearest degree, so that would be 37 degrees. And that's all we need to do for that one. All right, let's look at another problem. So you always want to see what you're given and set it up based off what you're given. So I've got theta. I can see I have the opposite side of theta, and I have the adjacent side, but I do not have the hypotenuse. Let me scoot Desmos out of the way for a minute. So go up to your notes, over to your notes, and see which one goes with opposite and adjacent, not the hypotenuse. And that would be the tangent. So to solve this problem, we need tangent. So we're going to set up tangent of theta. So tripping over apples. That's how I set that up. Tangent of theta equals opposite over adjacent. And I want to know theta, so I'll just keep that as my variable. Opposite was 7.7 because that's across the triangle from where theta is located. And the adjacent side is the 14. So that goes at the bottom. Same thing that we did before. You want to take the inverse tangent to get rid of tangent. And then just take the inverse tangent of both sides. That's going to help us to cancel out the tangent. We got theta by itself, and the rest we just type into the calculator. Okay, so we hit functions, trig, inverse tangent, and then 7.7 over 14. And then just make sure you hit degrees so you get the right answer. They're very different looking otherwise. So that looks like round to the nearest degree, and that would be 29 degrees for theta. All right, let's look at another question. Number 3, we're looking for a missing side of the triangle. So again, you still look at what you're given. I'm given this angle right here is 51 degrees. I have the adjacent side labeled as 10, and I'm looking for the hypotenuse. So think about adjacent and hypotenuse. And you go back to your notes and you see which one would help me. If I know the adjacent and the hypotenuse, then I'm going to need cosine. That's going to help me with this problem. So let's set it up. Cosine of theta equals adjacent, which was 10. Or actually, let's just write that formula first. Adjacent over hypotenuse. So cosine of theta equals 10 over x. Now we know theta is 51, so let's go ahead and plug that in for theta this time. So cosine of 51 degrees equals 10 over x. So something you could do is put a 1 underneath the left side, and then you could cross multiply. So you get cosine of 51 degrees times x equals 10 times 1, which is just 10. And then you can divide both sides by the cosine of 51. And you could actually go ahead and figure out what that number is, which might be a little, like visually, it might look a little easier. So let's do functions, and let's figure out what is the cosine of 51. Make sure you hit degree. So that's 0.63. And that just might look a little easier. You could do it either way though. So you could wait and divide, or you could go ahead and get that number. So 0.63 would cancel out, and we get 10 divided by 0.63 for our final answer, which is about 15.9. Let's just round to the nearest tenth. And we're looking for the side of a triangle, so you just want to make sure like it's not negative. That would not make any sense. So let's look at this last question. Look at what you're given. You have the angle of 60 degrees, you have the opposite side labeled as x, and then you have the hypotenuse labeled as 17. So if I have the opposite side, and I have the hypotenuse, and I have the angle, what would help me with that? I have opposite, and I have hypotenuse. So I see those right here. So sine is definitely going to be the way I want to set this up. So let's go back and set it up with sine of theta equals opposite over hypotenuse. So some old hippie helps me remember that. And so let's say sine of 60 equals the opposite, which is just x, but we'll figure that out, over hypotenuse, which is 17. So again, you could set this up as cross multiplying if that looks easier. And we could say x times 1 is just x. And then I've got 17 times the sine of 60. And we can type all of that into Desmos. So let's just type 17, get your sine from your menu for functions, and then put in 60, and then just double check it's still on degrees. So we get 14.7. All right, so that's it for right triangle trig.